Hello and welcome to another math video. Today we'll be taking a look at working with formulas. Here we have some examples of some formulas that we'll be working with. We've got the distance formula, the simple interest formula, and the perimeter of a rectangle. When we're talking formulas, really it's a mathematical model that describes a real situation, and we've got these models that are used so frequently and they exist already, we just call them formulas. If we are going to solve for a specified variable, here are some steps that we can follow in order to get that done. First, we want to transform the formula so that all terms containing that specified variable are on one side of the equation, and all terms without that variable are on the other side. So really that first step is two parts. Get all the variables you want to solve for on one side, anything else goes on the other. The second step we'll get to a bit later in our examples, and then the third step, really just divide by the coefficient on whatever you're trying to solve for. So in our first example, we are just solving for w, and so the only term with the w in it is the 2w, so we want to get any other term off of that side. So we get p minus 2l equals 2w. And from here, all we do is divide both sides of this equation by 2. And again, really not anything we can do with the p minus 2l over 2. The 2w, of course, becomes just w. So w ends up equaling p minus 2l over 2. And we'll take a look at a few other ways that we can write that. If you want to try the problem at the bottom there, I equals PRT, solving that for R. Go ahead and give that a shot. If you want to pause, then I'll go ahead and go through it in just a second. So if we look at what is being done to R, it's being multiplied by P and by T. So if we divide by PT, then those factors will cancel, and we get the I divided by PT equals R. Remember, when we are writing these formulas, it is improper to have a fraction or a decimal in either a numerator or denominator, so we want to make sure we do not have those. Here we're looking at a little bit different way of writing the formula for perimeter of a rectangle. We've got P equals 2, and then that quantity or sum, L plus W. We're going to solve for W again. To avoid having it look just like we just did, we're going to not distribute the 2, and instead we'll just decide to divide both sides by 2. So that gives us P over 2 equals L plus W. From there, all we do is subtract L from both sides of that equation, and so we end up with P over 2 minus L equals W. So you can see a little bit different way of writing that, but it's equivalent to the one that we just looked at. Again, we've got a formula for a trapezoid, area of a trapezoid here. You're going to do two things: solve it for h, and then you're going to start over and solve it for the capital B. Again, if you want to pause and try that one, and then resume the video, and I'll go through it as well. Alright, so I mentioned again that we do not want to have fractions or decimals in numerators or denominators. So first thing we want to do here is multiply both sides of this equation by 2. If you divide by half, you end up with a fraction in the denominator, which again is not proper to do. So when we multiply by the 2, we get 2 times a equals h times the sum of those bases. And here I'm doing part A, so I'm solving for h. H is being multiplied by the sum of those bases, so we just divide by the sum of those bases, and we end up with our formula solved for h. So 2a over the sum of those bases equals h. The second part of that asks us to solve for the capital B, so again we begin by multiplying by 2. Again, that avoids getting a fraction in the denominator. From here, if we are solving for b, one thing we can do is divide by h, so that we'll be able to work inside of those parentheses. We get 2a over h equals the sum of the bases. and from here then just subtract that b from both sides, and we end up with 2a over h minus that small b equals the capital B. Alright, so looking at this first example, we're solving this formula for L. Now if you notice, we have L in this term and L in this term. This is where we're going to need to use that second step in our process. But we need to begin with the first step, which says get all the terms that contain that variable on the same side, which is already done. But any term that does not have that variable, we need to get it to the other side. So we begin by subtracting 2hw from both sides of that equation. That gives us a minus 2hw, and that equals 2lw plus 2lh. Now it's very difficult to solve for L if there is more than one L in the equation. So what we can do, though, if there is an L in both of those terms, that means that L is a common factor there, so we can factor that L out. When we do, we're left with 2w plus 2h. And again, if you're thinking, why didn't we take the 2 out? The reason we did not do that is because we are not trying to solve for the 2, we're trying to solve for the L. Now we have L being multiplied by that sum of 2w plus 2h. So all we have to do to get the L by itself is divide by 2w plus 2h. And so our formula ends up getting L by itself. That's equal to a minus 2hw over 2w plus 2h. Now I want to go over this for a second. This is what our answer is going to look like. Notice in the numerator, the a minus 2hw, there are no common factors we can take out there. In the denominator, sure, we could take out a 2, but since there are no factors of 2 in the numerator that we can take out, there's no sense in really doing that. The thing that I want to emphasize is a lot of times students will think that, oh hey, I've got a w here and a w up here and we can cross those out. Again, the only time we can do that is when what we have on top and bottom are factors for the top and bottom. So if we go back to here, the 2w plus 2h on the top is a factor for that numerator. It's L multiplied by that 2w plus 2h. So then when we have that same factor in the denominator, then we can go ahead and cancel out that entire factor. So we're canceling out the 2w plus 2h with a 2w plus 2h. And so that's how we can cancel things out. So just be careful. Don't fall into that trap of just crossing things out because they're on the top and the bottom. If you want to go ahead and give number 15 a shot here, again you can pause and then I'll go ahead and go through that once you're done. So this is similar to the one we just looked at. There's r in two places. We do need to get the r's on the same side. It doesn't make a big difference whether we go for the left or the right, but I think I will go for the right side. So if I subtract AR, that will get the R's on the right. That means I don't want the 3Y on the right, so I'll add that to both sides. Now there aren't really any like terms to combine here, so we just get 2K plus 3Y equals R minus AR. So now, notice on the right side there is a common factor of R that we can take out. Now sometimes people have a hard time with this. Remember, when we have R, that's the same as 1R. So you factor an R out of 1R, you get 1, and then minus the A. And the 2K plus 3Y just stays the same. Now from here we can see what R is being multiplied by. It's being multiplied by 1 minus A, so we'll divide by 1 minus A. And we end up with our formula solve for R. So R equals 2K plus 3Y over 1 minus A. And I call it a formula, but really it's not. It's just an equation that we have. It doesn't represent anything in the real world, but that is what it looks like if we solve it for R. Here we will take a look at using our distance, rate, and time formula. Normally it's solved for distance like it is here, but we can solve it for either the rate or the time depending on what we're dealing with. So in example 4, we've got Janet. It took her 3/4 of an hour to drive a distance of 15 miles. Question, what was her average speed? So we know the time was 3/4 of an hour. We know the distance was 15 miles. We are trying to find the rate. So if we solve the distance formula, distance, rate, and time formula for the rate, then we will have it already set up when we plug in our values. So distance equals rate times time. If we divide both sides by the time, we determine that the rate is equal to the distance divided by the time, which allows us to plug in our values directly. So we get 15 divided by 3/4. Now, I mentioned earlier, of course, it's not really proper to have a fraction in a denominator because it's kind of a mess when we look at that. Notice, though, again, that fraction is the same as a division problem. So it's 15 divided by 3/4. And instead of dividing by 3/4, we could instead multiply by its reciprocal. So you can think your way through that to the point where it should make sense. And then we should be able to come up with the 20 as the answer. 4/3 of 15 is 20. And so that's 20 miles per hour. And so that would be Janet's average speed. If you want to go ahead and give number 19 a try there with Jeff Gordon, and if you want to pause, then I'll go ahead and go through it once you resume. Okay, so for Jeff Gordon, it was a 500-mile race, the Daytona 500. See, he won with a speed of 135.173 miles per hour. That's some pretty accurate measurement there, down to the thousandth of a mile per hour. And they want us to find the time. So looking for the time in this case. So again, we've got our distance, rate, and time formula. If we solve it for time, so again, distance equals rate times time. If we solve it for time, we're dividing by the rate. We find out time equals distance divided by rate. So we have those values. So the time would equal 500 divided by 135.173, and that would give us our answer. And so the calculator tells me that that is about 3.699 hours when I round to the nearest thousandth. Of course, I'm sure this would probably be converted to minutes and seconds, but we're not going to worry about that right now. Alright, so here we're going to transition into some percent problems. There is a bit of a formula for this. I don't particularly care for it all that much, but if you take the part divided by the whole, you get the percent over 100. In other words, you get your decimal answer. So there's a few different ways we can arrange that. The part equals the percent over 100 times the whole is one way that we can use that. And so in this case, we've got a 50-liter mixture of acid and water. Contains 10 liters of acid. What is the percent of acid in the mixture? So in this case, we have the part is 10 liters of acid. We have the whole thing is 50-liter mix of acid and water. And so 10 over 50, which would be 1/5, equals 0.2. So again, that's the percent over 100 is 0.2, which would be 20%. And so that's how we can use our numbers in order to find the percent of that mixture that is acid. The second example we have here, we've got a savings account that's got a balance of $3,550, earned 6% interest in 1 year. How much interest is earned? This is really an application of our simple interest formula, where the principal is $3,550. The interest rate is 6%. However, you need to make sure that you use 0.06 here. If you used 6, that would be 600%, which of course would give you way too much money. You should figure that out. And then they say 1 year, so the time would be 1 year for that one. So the interest earned would equal the principal of $3,550 times the rate of 0.06 multiplied by the number of years, which is 1. And of course we'll let the calculator figure that out for us. So really 6% of $3,550, they would earn $213 in interest on that savings account balance. So if you want to go ahead and give these two problems a shot, they're like the ones that I just went through. If you want to pause, then I'll go ahead and go through these once you resume. So looking at number 31, it's a total of 36 ounces of liquid. There's 9 ounces of pure alcohol in the mixture. What percent of the mixture is water and what percent is alcohol? So a little twist there, asking for both pieces. But we can put the part 9 over the whole 36. Now this does reduce. It's 1/4, which hopefully you recognize as 0.25, which of course we should be able to convert to 25%. And that would be 25% alcohol. There's a couple different ways we could figure out the percentage of water. I would just figure, since it's 25% alcohol, then it must be 75% water. And then number 33, the real estate agent earned $6,300 commission on a property sale of $210,000. What is her rate of commission? So it's really that commission over the total sale that will end up telling us her rate of commission, which again is really her percent. You know, what percent does she get? And that turns out to be exactly 0.03, which would be the same as 3%. Here we've got some data about pets. So in 2005, people in the United States spent an estimated $35.9 billion on their pets. This graph shows the different percentages and how that breaks down. They want us to use that information to determine how much was spent on pet food. So pet food being 40.2% of the entire $35.9 billion. So we want to find 40.2%. So again, if we have that formula where it's the part over the whole equals the percent over 100, again that can also be written as percent over 100, oops, not 1,000, percent over 100 multiplied by the whole will equal the part. And so that's what we will use here. So the percentage is 40.2, so divide that by 100, we have 0.402. Multiply that by the $35.9 billion, and I'm okay with leaving that in terms of billions of dollars because this will still be several $billion. And that ends up giving us $14.4318 billion, and that's exactly what we get from that. I would not round that at all, largely because that 4318 is $431,800,000 when we're talking in terms of billions of dollars, so we don't want to round that off. And if you want to give this problem a try, it's similar to the pet food question. Average middle income family is going to spend $242,070 to raise a child born in 2004 from birth to age 17. The question is how much would be spent on housing for the child. So if you want to pause, I'll go ahead and go through this once you resume. So really we are trying to find the housing cost, which is 34% of the total. So we find 34%, which would be 0.34 of the total, $242,070. That will equal how much was spent on housing out of that 242. Let's get that right. So this is a 2, not a 0. So finding that number will give us how much was spent on housing. And we end up getting $82,303.80. And since it is money, I will emphasize the 0 at the end of that, just so it's not 0.8. It would look a little funny. Well, thank you for watching, and hopefully you found this to be helpful.